Okay, so hello and welcome to this session. It's D428 supporting later lifecycle phases. We have three presenters, three speakers this afternoon here in this session. So the first speaker will be Markus Doellken. Markus Doellken is scientific assistant here at KIT in Karlsruhe, where I'm also from. His research interest includes use of eye tracking and machine learning in product development. He also is teaching mechatronic systems and product, and as well leadership of interdisciplinary teams. So his paper he's presenting has the title Challenges Faced by Design Engineers when Considering Manufacturing in Design, an Interview Study. Our second presenter is Mr. Khalid. So he's an experienced professional with a demonstrated history of working in the supply chain and maintenance operations. So skilled in machine learning, big data, data analytics, and linear programming. So he has a master's degree focused in engineering, industrial management from Denmark Teknisk Universitet. His paper has the title, A Design Support Tool for Improving Maintenance Scheduling Process. Then, last but not least, our third presenter is Mr. Campi from Italy. So he has also a master's degree in mechanical engineering from Università Politecnica del Marche in Italy. I'm not sure if I'm pronouncing correct. So he started his PhD course in industrial engineering at the Department of Industrial Engineering and Mathematical Sciences. So at the Università Politecnica delle Marche in November 2017. So his PhD goal is the identification of a method that adapts to business needs and with which companies could be evaluate the manufacturing costs in the preliminary design phases. His research activity is mainly focused on design for manufacturing, design to costs, life cycle costing, and analytical and/or parametric cost models for mechanical components. So my name is Markus Spadinger. I'm chairing this session in the name of Professor Albers. So I will also try to manage all of your questions. So please feel free to write your questions in the chat. So also please indicate to which presenter, to which topic your question is referring to. If you do not want to write down your questions, you can also, of course, use your microphone later and put on your video and directly ask the questions here to our speakers. So I think we can directly start with the first presentation, with the first pre-recorded video from Markus Doellken.
Hi everyone, welcome to the presentation of our research project. Let me briefly introduce myself. My name is Markus Doellken. I'm scientific assistant and part of the IPEC, Institute of Product Engineering, that is part of Karlsruhe Institute of Technology. I am delighted to be here today to talk to you about challenges faced by design engineers when considering manufacturing and design, an interview study. I opened the session D428, supporting later life cycle phases. The consideration of the manufacturing and design leads to an increase of product quality and to a decrease of costs. While on the one hand, the design engineer has to fulfill the function through a suitable design, on the other hand, a manufacturing optimized and cost-effective realization has yet to be fulfilled. The design engineer defines the embodiment of the design and is expected to consider the influences of manufacturing during already the early phase of the design. The problem here is only a few studies are known that have attempted to prove that manufacturing-oriented support through design rules has a positive influence on the design process. The studies point out that an evaluation of, for example, manufacturing-oriented support is lacking. Furthermore, a need for the development of further design rules is also reported. One challenge here might be that for each manufacturing process, a detailed expert knowledge, for example, is often necessary to create a reasonable and realistic design. However, there is no comprehensive impression of the challenges faced by a design engineer when considering manufacturing in the entire design process. From the implementation of these ideas to a draft to the manufacturing-oriented product, we have the research question: what challenges are encountered by design engineers from this implementation of the idea as to draft to the construction of a product ready for the manufacturing? Design engineers from 7 different companies took part in our interview study within the German engineering industry. In total, 15 participants, 1 female and 14 male, with work experience from less than 1 year up to 30 years in the field of sheet metal design, took part in this study. The participants cover a wide range of sheet metal design because there is a variation of internal and external manufacturing line. For example, the sheet metal thickness, small till large scale manufacturing among the participants. A questionnaire was developed prior to the start of the presented interview study. Therefore, the questions were pre-selected using the 3-step Delphi method of Ocoli and Pawlowski. A total of 46 selected questions were categorized into activities which occur within the design process. First, searching for concepts and the design. Second, considering manufacturing in design. And third, evaluating concepts and detailing the embodiment of the design. The interviews were conducted individually and on-site at the companies. The interviews were semi-structured and lasted an average about 60 minutes. An interview guide who attached importance to an open discussion instead of a questionnaire chaired the interviews. The 4 challenges in considering the manufacturing and design are described in this paper. The detailed and manufacturing specific knowledge is necessary, but for the design engineers not sufficient. The design engineers are not pre-thinking the manufacturing processes, although these have a very high impact on the embodiment and thus ultimately on the costs. The second step is the synthesis. The design engineers, they cannot create concepts that fully use the manufacturing potential in terms of costs. The key factors in this case are the number of parts, the number of process steps. A new awareness must be created in order to ensure that design engineers can exploit the full potential of a manufacturing process. Within this concept phase, the lack of manufacturing specific knowledge has an impact on the design evaluation and its processes. For selecting a concept, the design engineer has difficulties to analyze its feasibility due to a lack of expertise. Support could provide valuable information to increase this knowledge. In practice, however, support of programs are usually only available to the manufacturing department and not to the design engineer. Depending on the manufacturing process, there are different parameters that have an impact on costs and must be determined during the early design stages. For complete evaluation of different concepts, however, a precise knowledge of these parameters and their impact on cost is necessary. But herefore, the dimension of cost drivers is unknown, and the optimization in the early stages of design is difficult. With this small overview, I want to finish my presentation, and I want to say thank you for your audience and for your listening. We are happy to listen to your questions and for further discussion.
Hello everyone, my name is Waqas Khalid and I'm a PhD student at Technical University of Denmark. I'm going to present a research paper which has a title, A Design Support Tool for Improving Maintenance Scheduling Process. This research work has been funded by the Danish Hydrocarbon Research and Technology Center and has been carried out in collaboration with an offshore oil and gas company called Doellken. Let's move on to the slide. In asset-intensive industries, the maintenance is managed by a maintenance management system, which is called CMMS. And this maintenance schedule is a core and vital part of the CMMS system. In this system, the maintenance work, they pour in with the passage of time, and they can be of different types, for example, preventive maintenance works or corrective maintenance works. And then the maintenance scheduler, they carried out the capacity leveling exercises on these maintenance jobs, and these capacity leveling exercises are called long-term, medium-term, and short-term capacity leveling exercises according to the time where they lie in. And after these capacity leveling exercises, the maintenance schedulers make a final log schedule, which is then forwarded to the technicians and mechanics who are working offshore to carry out this maintenance plan. There are a lot of challenges and requirements while designing this maintenance schedule that maintenance schedulers need to be very careful about. For example, we have to manage the resource allocations, meaning that we have to allocate the right person to the right job. So if there is a work which needs to be done by a mechanic, so we have to make sure that we are allocating correctly, and so on. Additionally, we also have to manage the number of people which we are assigning work at the same time on the offshore platform, because there are some limit on the maximum number of people that we can accommodate on a particular platform. So we have to make sure that we are not exceeding that capacity. In addition, we also have to manage the risks which are associated with the maintenance job. So we have to make sure that we prioritize the more critical job rather than the less critical one. And then there can be some dependencies among the operations of different maintenance jobs. For example, if two operations need to start together, or one operation needs to be finished first in order for the second one to start. So we have to make sure that we are following these dependencies. And we also have to take care of the start date of the different maintenance jobs, and we have to make sure that the material is arrived before the starting of the maintenance jobs at the offshore platforms. Let's move on to the next slide. So as we can see that there are actually a lot of requirements and challenges that the maintenance scheduler have to be very careful about. So that is why there's a lot of extensive work that needs to be carried out. So they need kind of a support from a software or from a computer, so which can help them in designing this maintenance schedule. And this is what actually we have done. So what we have done is that we have created a design support tool which helps the maintenance scheduler in carrying out these long-term and medium-term capacity leveling exercises. And how this tool works, it basically a combination of a heuristic algorithm and a mathematical model, where we try to minimize the weighted lateness or delay of the jobs. But I'm not going to spend time on the details of it, but I will present the results. So these are some of the results that have been carried out in different case studies on offshore platforms. So in the left-hand side, we can see the graph where we see how the distribution of workload looks before and after the use of this tool. And in this graph on the right side, we see that how the capacity utilization has been improved by the use of this tool. And in the graph below, we show that the people requirement to carry out the same amount of work has been reduced. I think that's it from my side. Thank you very much.
Hi everyone, I'm Federico Campi, a PhD student of Università Politecnica delle Marche, and the title of the paper that I'm going to present is an analytical cost model for investment casting. And there is the presentation outline. We will start with the research motivation and the objective of the work. After that, I'm going to show you a brief background of the cost estimation methods. and the cost model developed for investment casting process. At the end, I also present the conclusion and the future goals. Investment casting has been widely used process for centuries. It is known for its ability to produce components of excellent surface finish, dimensional accuracy, and complex shapes. It is especially useful for making castings of complex and infinite shape geometry, where machining may not be possible or too wasteful. In literature, there are very few scientific papers on early cost estimation of investment casting products. So, the work presented in this paper attempts to bridge this gap by developing an analytical cost model for investment casting cost estimation, using Botrovia tool as reference. The proposed cost model may be used by design and cost engineers for evaluating the cost of the entire investment casting process. During the product development process, cost plays a critical role and drives most of the technical and technological solution. It's well known that product design and engineering phase consume approximately 10% of the total budget for a new project, but typically 8% of manufacturing costs are determined by such phase. Several cost estimation approaches are available today for evaluating product cost at design stage. They can be grouped in two main families, the qualitative methods and the quantitative methods. Investment casting process is composed by many phases, and they are shown in this slide. The process starts with the fabrication of walls and plastic parts and assembled in a cluster. The cluster is invested into ceramic slurry removed and then covered with a stucco material. Once the ceramic shell mold is completely dry, the pattern is melted out, leaving cavities in the shape of the parts. The mold is fired to reach its final thread, and while the mold is still hot, molten metal is poured into the cavity and allowed to solidify. The mold material is then coated off the casting, and the parts are separated. The analytical cost model for investment casting, developed in this work, is an improvement of the one proposed by Detroit in the US, taken as a reference. The approach for this improvement consists in 4 steps, hereafter summarized. The first step consists in collecting equations and data available in the reference. The result consists in an electronic spreadsheet to be used for preliminary estimating of the manufacturing cost for investment casting. After that, 8 components were selected in cooperation with you find with the aim to evaluate the most cost-effective investment casting phase, both in manual production and automatic production. The second step consists in organizing 2 workshops with the selected funding, equipped with manual, the first funding, and automatic production line. The aims of this workshop were the presentation of the elaborated data in previous step and to obtain information for the improvement of the reference cost model. During the third step, all the improvement to the investment casting cost model proposed in the reference have been integrated in an electronic spreadsheet. In this manner, it was possible to have an updated cost breakdown for investment casting. Based on the proposed cost model, two sensitivity analyses were performed for evaluating the relationship between the product and process cost driver with the process and raw material cost. The fourth step aimed to evaluate the robustness of the proposed cost model. The cost model presented in the previous section was used for estimating the investment casting process cost of 8 components, different weight and materials. Results were organized in 2 datasets for simulated 2 different scenarios. In the first scenario, parts are manufactured by a foundry located in Italy and equipped with the manual line, while in the second scenario, components are realized by a foundry employing an automatic line. Then, the result of the paper are an investment casting cost estimation model with a lower deviation from the actual cost compared to the reference cost model. The future work will aim to evaluate the robustness of this cost model for tiny components, and the development of parametric cost estimation model that can be used early in the design phase. Thank you for your attention.
So thank you very much for those 3 very interesting contributions. Very nice research carried out. So far, unfortunately, we have no direct question which was sent to me. We have one question which was directly addressed to you, Markus Doellken. But I think we can anyway start the discussion from this point on. So I think what you proposed was very interesting. because we today face all the time challenges which occur from this gap we have in many cases, or this missing link directly between the design process and the manufacturing process of components. So what do you think, what should be done to overcome this gap? So of course you're right now focusing on looking into it, getting an impression what are significant problems towards manufacturing, but what could be done to overcome this problem, to solve it?
Thank you, Markus. This is very interesting. First, I think from the plenary session before, the last statement was that AI helps us, artificial intelligence helps us, but the main core knowledge for designing is so beneficial and necessary. And that's why I went to the industry companies to really to find out, to ask again, do the design engineers nowadays have this knowledge if they work every day even with the same material or with different process manufacturing steps? That's why also the question from Dorian Marjanovic, thank you for the question. The manufacturing knowledge is indeed too general, but it was very surprising. There was a big lack of specific manufacturing knowledge from the design engineer, and I think it's crucial to know how to optimize my concept before I give it to the manufacturing department. How to overcome this problem? There are plenty of support for the late, like design for manufacturing. I think it's necessary that the design engineer again pre-thinks the manufacturing. Yeah. That's why I also have a question to you, Mr. Campi, Federico. The engineers which I asked, they had huge problems to know the cost drivers. I call it cost drivers in their design. They didn't know what to change to make a better design in a cost-efficient way. Could your analytical cost model support the engineer in this case?
Maybe. Also, our analytical cost estimation is for not early design, but for not conceptual over the conceptual. The CAD, the 3D model of the part are produced, so the designer know approximately the final part, the final design of the part, and he can modify some particular of the part, but not the initial the starting design.
Mm-hmm. So I think that's a very important aspect you're mentioning, Federico. So of course your cost estimation, so your analytical model gets more and more accurate as further you proceed in your development process. But is there a specific point in the development process where you can decide to use, or where it makes sense to use your analytical cost model, and which information is required at this point?
Sorry, not understand well the question.
Okay.
You mean that use this analytical process in early phase, or another type of cost model for early phase?
So to rephrase it, how much information is necessary to be able to give data to your model?
There are some information are necessary. For example, the dimension of the part, tolerance, roughness, and also the number of surface. These are I don't know, parameter for the analytical cost, for our analytical cost model.
Mm-hmm. Okay, and so what would you say are the limitations of your modeling? So can this be applied in every company using this manufacturing process, or is there also a specific knowledge necessary to use it, or is there to formulate it vice versa? Do you have to include specific knowledge and specific data which comes only from the company you tested it on? So towards your validation you had.
So interesting question. The cost model can be used for all the company, approximately, but there are some problem, and this is a future improvement in small parts. In fact, in small parts there are some problem with the cost, the precision of cost. Some small part jewelry under 200 grams. These small part have some problem with the cost estimation, because the precision is very important in this condition.
Okay, and can you please also explain a little bit more in detail what you meant with your reference cost model? So what is included in this reference cost model?
My reference cost model is designed for manufacturing and assembly. The program was developed by Boothroyd in the US. This program is very interesting and is approximately the only one in the literature with an analytical cost model for investment casting. There are a lack of cost model, analytical cost for this type of process. So we start with this reference, and we modify some particular inside him inside it. For example, the investment casting, there is a pouring cap for the metal. So design for manufacturing and assembly doesn't consider the program, doesn't consider this part, and it consider this part the same for all the type of the design. So we modify, for example, we add the pouring cap, and which is different in base of the dimension of the part. Also, we add some improvement considering tolerance of the part and the roughness. We change essentially the coefficient for this.
I have one question.
Yes, please.
Okay.
Does the design engineer, if he used the cost model, can he, during his design process, figure out what he has to change to have a more cost-efficient part? Is there kind of interpretation directly for the engineer?
Okay. Yeah, the engineer could use this method for I don't know, for select the best, the worst, the most expensive section of the cost breakdown. So he could, sorry, Matt. Okay.
Just whether the engineer can find out what has the biggest impact on his costs, and then, like Professor Marjanovic wrote, this is the difference between experts and novice, who I also would say who know the experts. They directly design the product in the way the manufacturing process will be.
And this I could not see so far in my interviews. That's why I was asking.
Okay, we also made not an interview, but a workshop with engineers and with foundry. So in particular, we made this workshop with not the designer of the part, but with the supplier. So we have information about the technological process, but not the designer, but not the design in particular of the process.
Okay, thank you very much. So before we come to your presentation, Waqas, I want to ask one question from Professor Marjanovic to all of you. So he states in his comment from the viewpoint of a traditional mechanical engineering designer. So for him, there's only, or you could say, there's only one logical manufacturing process for a well-designed part. So would you please all comment on that? So who wants to start?
I can start.
Yes, please.
I totally agree to this comment. This is how I got taught also to the engineering process. I was surprised that this comment I could not find in the industry anymore. The design engineer knows for what kind of manufacturing process he designs his product, but he's not aware of how to well design the part that is used the potential of the manufacturing process. So I saw the big gap between the design engineer on his desk and the manufacturing department or the manufacturing process in a different building in a different city, and there was a miscommunication.
Mm-hmm. One question in between. Do you think this is a question of communication within a company, or is this more a question of education?
I would not narrow it down to communication. There's too less.
Mm-hmm.
Education in the sense also how we could hear in the plenary session before. There are so much knowledge, so many details. The manufacturing process develops so fast that a well-designed part, as mentioned from Professor Marjanovic, you need to be a specialist in your manufacturing process as well.
Okay, so
not only knowledge, also the clever, the complexity of our parts it's growing.
Okay, so Mr. Khalid, do you think this would be a question of possible design support tools as well? We cannot hear you.
Mr. Khalid, you're muted. Okay. If something is not okay, you can refresh the page. Just press F5 button, and then you share audio and video again, and then should be fine.
Okay, so I think in the meantime, you, Federico, maybe could also answer, what do you think, is there only one manufacturing process for a well-designed part?
Oh, so sorry, you mean?
So the same question we had for Markus Doellken already.
Okay.
So if there is only one logical manufacturing process for a well-designed part.
No, I also it's I don't know. So. The problem is the gap between the design and the manufacturing. generally there are two different in general two different sides. In fact, sometimes in the manufacturing have problem to support what the design want. So in fact is very interesting. For example, group some design rules. In this way, the designer could be produce a better part, a better design, and also respect the manufacturing limits, the manufacturing constraints.
Okay. Very nice. So, Waqas, maybe it's now working.
Yeah,
Yes.
can you hear me now?
Perfect. Great.
Sorry about that before.
Good to have you back.
So, yes, thank you. So yes, I think I do agree with this statement. So I'm not actually a design engineer, but I think this statement makes sense. So, but even if there is only one logical manufacturing process for a well-designed part, but I think the variabilities associated with this manufacturing process, we do have to incorporate that into the design phase, in the early phases of the design. So yes, I think the statement is correct. And there is one more thing that I think I would like to mention here, because when I think we are generally speaking about the design, but we are probably speaking about the physical design, like a product or a system or something. But there might be like a service design or something, or a design of a process, which is something sometimes the people do not pay much attention to. The study, for example, the presentation that I have presented here about the maintenance scheduling process. So I think we also have to kind of pay the importance to the design of the process itself, and it can have actually multiple dimensions as well. For example, the maintenance itself, sometimes it gets ignored in the early phases of the design, and sometimes we have like huge systems or the system of systems. For example, the maintenance of your oil and gas platform. So they are like very complex systems. And I think here it is also important to mention, for example, in the oil and gas, especially in the offshore, the maintenance accounts for more than 40% of the operating expenditures. So we are spending a lot of money on maintaining those equipments and systems. And sometimes this maintenance aspect is totally ignored in the early phases of the design. So I think it is also important, and it is crucial to actually incorporate this knowledge, the knowledge of the maintenance, how to maintain those equipment, and then put that knowledge into the early phases of the design. And there is a term which is called a design for maintenance. So I think the designers, they should probably also take a look at this and then pay more importance to the maintenance factor of the product.
Okay, very good answer. So design for X was also what came up to my mind when you mentioned it. So the other presenters, do you also want to comment on that? So what do you think about design for maintenance, design for manufacturing? Of course, what has to be done? Do we need changes in our product development processes? How to overcome this challenge we have here, which we're facing?
I would say it's interesting how this session is called, supporting later life cycle phases. Somehow it's, I have a feeling that we make research on the later life cycle phases, but we figure out that all the decisions are made in the early design phase. And so Waqas, what you said, design for maintenance should also be considered in the beginning of the design process. The challenges I found, they should be considered in the beginning, in the early design phases. And the cost model anyway is always crucial from the beginning till the end.
Yes, I think sometimes the industries they do have like the historical data on maintenance. So and also the expertise, the people who design those equipment and the people who maintain those equipments or who are responsible for operations of those equipments and systems. I think they should sit together during the early design phase, and the communication is probably the key. So they should communicate the challenges that they face during the operations phase, and so that in the early phase they can get that knowledge early on, and then when they design, so they have this perspective of the maintenance of the equipment. If the equipment, the system that they are designing, is it maintainable? Do we will have the like more reliable and system, and the availability of the system? They should probably also consider those in the early design of the phases of the in the early design phase. So I think the communication between the operating department, production departments, and the design department, and also of course the manufacturing department. So they should all probably have a strong communication, and they should share the knowledge and the expertise that they have.
Okay, so you're emphasizing the communication part. That's there was a point, Markus, you mentioned it's not just communication; it's also a question how to deal with this complex system, how to integrate the information we need. So, Federico, what do you think could be a possible approach to deal with this?
So, possible for I don't allow. So the design for manufacturing is very important because it could modify the connection between the manufacturing phase and designer. So I think that correct design in previous phase is fundamental for avoid excessive cost or the not factibility of a part. Also, is important, for example, use some rules and take these rules from manufacturing. Takes these rules from manufacturing and gave them to the designer. In this way, the designer could be a better design of the part, and also a less costly part.
Mm-hmm. So you have a strong background in mathematical programming as well. So do you think it could be a solution to have even more model-based approaches in the development of products, so to also include knowledge on costs, knowledge on manufacturing processes, as well as on maintenance, for example, into early design phases via a analytical model?
I'm not mathematical. I'm an engineer. So the problem I'm in the early phase of the study in non-analytical in artificial neural network and also machine learning. I'm in the beginning of this phase, and I will study for this sector, this sector of for cost, for parametric cost in early phase when the part are not well defined, and also there are few information about the parts, about the design or the final parts.
Okay.
Maybe I can comment on that a little.
Yes, please.
So I think if we talk about the mathematical modeling or the optimization, so probably if we talk about the design optimization, then probably in that domain, in that scope, we can use the mathematical optimization. Yes, and my answer is yes, probably this can be used in the early design phases, but we do have to have like the clear the information, the data that is required to actually to carry out this type of analytical studies. And this can be, for example, a multi-criteria optimization study as well, where you try to optimize, for example, the cost or the manufacturing cost or the reliability or the maintainability of the equipment. So I think yes, it would be quite interesting to use these types of tools in the early design phases. Yes.
Okay, thank you. Further comments or questions?
Not right now, thank you.
Okay, so I'm looking in the chat if there's some more questions, but seems not to be the case. Okay, so if there aren't any further questions, I would propose to close the session a little bit before time. So thank you very much for your contributions. Also,
thank you.
Thank you very much. So we have now one further question. So what would be the further research, of course, and upcoming issues in your projects? Of course, we can go on that question. We have enough time for it. So thank you, Professor Maranovic. So I would go from Mr. Khalid to Mr. Campi and you, Markus, in the end. So what are the next steps? What is further research, and what are upcoming issues you will face?
Was it me who should start first? Or?
Yes, please. Yes.
Sorry. Because I think this paper that I wrote for this conference, it was almost 1 year ago, and I think there have been some further developments on this study as well. So the next phases is to use some other heuristics and meta heuristics and some AI-based tools that we can use to support these maintenance scheduling processes. Yes, and there is a little bit progress, actually a lot of progress on this currently, and the issues is always the computation time, I would say. So because in the optimization problem, you eventually end up with a lot of data, and then you have a computer which does not have the capacity to calculate and find the optimal solution, you know. So this problem is always there. So this is why we are trying to solve it. And now this is why we have moved from mathematical optimization towards heuristics and meta heuristics, where we can generate more like close to optimal solution, but not the optimal one. But I think in the industry, usually this is the case. I think out of 100%, more than 90% of the cases, the industry, the people, they are not interested in finding the optimal solution, but just in the feasible solution. And I think this is the case in our case as well. But we are working on it, and I think we have made progress on this. Thank you.
Okay, one additional question to what you said. Yes. Of course, if you go to heuristics, the quality of your solutions might decrease instead of have increasing solutions. But how are you able to decide if you are close enough to the optimal solution in the end?
Yes, so we in that case we have to kind of make some analysis on the smaller data sets. Mm-hmm. So for example, so there is a scheduling process. There is a data which is like, let's say we have to make a maintenance schedule for a whole year or for next 6 months or something. Mm-hmm. Then the amount of data associated with that time horizon would be quite significant. So, and I think the maintenance, the mathematical model will not be able to calculate that much amount of data. So what we do then, so we make small data sets, like let's say for a few days or a few weeks or something, and then we run it on the mathematical model, and then we get the optimal solution, And then we use the same data, and then we run the heuristic models. And then we can make apple-to-apple comparison. So we can see, okay, how much close is the heuristic solution to the optimal one. And in that way, we can check, we can evaluate and assess the performance of the heuristic models.
Okay.
And this is what we are doing right now. So, yes.
Okay. Can you give us a hint how much time you can save by changing the optimization procedure?
Yes,
So
yes.
to hit the heuristic model, yes.
Yes. So, for example, the very recent one, I just run this algorithm yesterday, and then it took 9 hours for the heuristic to run the model, to run the data, and it was the maintenance schedule for the whole next year. And it took almost 3 hours to build the initial solution, and then we ran it for additional 6 hours for the optimization. But obviously, if we run this on the mathematical models, and then it will probably run for the whole year, and we will not be able to get the results.
Okay, so that's a significant improvement, of course. Yes.
Yes. Yeah.
Okay, thank you. So also, yes, please comment.
How do you know what is? You said you compare heuristic with optimal. What is optimal in this case?
Yes, so in the optimization, so we sometimes we have to define like objective criteria. So in this case, the objective, because this risk and safety is the most important thing in the offshore oil and gas industry. So in this case, so we try to optimize we try to minimize the risk associated with the maintenance jobs. And what do I mean by that is that we have to minimize the delayness of the jobs. So we have a lot of maintenance work, different types of maintenance work. It can be corrective, preventive, predictive, condition-based inspection, and etc. And then, but we have a very limited capacity. So in that situation, we have to make decision. Okay, which ones we have to prioritize, and which ones we can delay, because we have a very limited number of people who can carry out the maintenance work. So in this case, we define the objective criteria. So in this case, it is the risk. In very simple terms, it's risk, and in more technical terms, it's the lateness, the weighted lateness of the maintenance jobs. So then we try to get this optimal value. How much can we delay the jobs without compromising the risk, and using the people as optimally as possible.
Okay, thank you very much again. So then back to the question we had. So what would be the further research? What are possible upcoming issues? To go directly to you, Markus.
So Professor Majanovic also asked about the key research issue. So
yes, it's directly related to it.
Issue is the design cognition. So I'm very interested in how the designer as a human being, how he behaves, how is his design process steps, how does he, where does he have challenges while designing? And so this first interview study was the qualitative data in my research, and I further went on with an experimental design in which I give to the engineers and to Novice, I give tasks which are related to these challenges in design for manufacturing. And then, for example, with I collect their eye tracking data to compare their visual behavior during the design. This is my further research and my key research issue. And especially here in the gap between the early design phases and the consideration of design for manufacturing is really, really interesting, and there's a lot of potential still ongoing.
Okay, thank you. So also same question again for you, Federico.
My research is cost estimation and design for manufacturing. So my presentation, my paper focus is focused in analytical cost, and the future research, in fact, is to develop a new design, new cost model, but for early design. For example, in this case, a parametric cost model with lower, with a few parameters to insert, and also my and also another research field is I said previously the design for manufacturing. In fact, we group some rule from the manufacturer, from the not also the designer, but also the from the designer, from the manufacturing, in to develop a tool, a software for calculate design issue in early and in design phase of a part.
Okay, so any further comments from the audience or the presenters?
Thank you for interesting discussion.
Okay, so I think now we should close. I was already remembered. So the closing event starts at 4:15 p.m. So thank you very much to all of you for your contributions, for your interesting presentations, and all the very interesting discussion. Was really a pleasure moderating the session, and hope to see you again in the next design conference, maybe also in person. So stay healthy, and hopefully see each other again in person sometime. Thank you very much. Enjoy the rest of the day. Have a nice evening.
Thank you.
Goodbye.
Bye-bye.
Bye.
Thank you. Bye-bye.
Thank you, Mario, as well.
Thank you.